Let's have a look at question 8 now. So we want to investigate the relationship between the price of a house and the size of that house. We have the regression line based on this test, so to speak, on this relationship. Y is going to be the house price, so this is our HP, and X is going to be the house size, and we also have the correlation coefficient. Now that said, we want to know whether the variance of the house prices is larger than the variance of the house sizes. Okay, let's first deconstruct this sentence in variables, right, to work with letters because it's faster. What are the house prices? The Y values, right? So we want to know the variance of the outcomes, the variance of the house prices. Well, if we speak about the variance, that's the same as speaking about standard deviation, because the standard deviation is the square root of the variance. The square root of the variance. So in that sense, we are basically researching whether the standard deviation of Y is going to be greater than the standard deviation of X. That's the same thing. Okay, now how do we interpret this regression? Brief intuition real fast. The idea is that we want to predict stuff, right? We're predicting house prices based on house sizes. What we have over here is the coefficient. So this is 94.45. This is the rate of change. This is the slope, remember, from math. This is the change in Y due to the change in X. In other words, when the house size, how do we measure the house size? In square feet. So if the house size increases by 1 square, how do you read that? Foot? Anyway, something like that. By 1 unit, so to speak, the house price, the dependent variable, the outcome variable, increases by 94.45 thousands of dollars over here. So that's how we measure the units, 94.45 units, and that is thousands of dollars. So this is what the coefficient is showing us, the relationship. Now we also have association between the correlation coefficient and the standard deviation, and that is this: the coefficient of the regression line, which is this one, is going to be equal to the correlation coefficient, which is given as R, so that's R, times the ratio of the standard deviations, so the standard deviation of Y divided by the standard deviation of X. Let's substitute all the data to see what we find. We will have the coefficient of the regression, which is 94.45 equals to the correlation coefficient, which is equal to 0.77 times the ratio of the standard deviations. And there's nothing given to us about the standard deviations, so we write them like that. Now let's do the math to see what that ratio is. Sy over Sx, what's that? Sy divided by Sx is equal to 94.45 divided by 0.77. If we do the math, that's equal to 122.7. Let's do a cross multiplication to find out how this looks like. Sy is equal to Sx, is going to be the standard deviation of X, times 122.7. So the standard deviation of Y is going to be 122.7 times bigger than the standard deviation of X, meaning that the standard deviation of Y is greater than the standard deviation of X. And if the standard deviation of Y is greater than the standard deviation of X, is the same as saying that the variance of Y is greater than the variance of X. So this was the relationship that we had to check. This is the result. It seems to be true, so the answer to the question here is true, and we are done.